Sweet. Okay, so before we start, maybe I'll just poll the room to see what people want to talk about, think about, focus on, where people are at. Maybe I'll just do a raise your hand if you've heard of ZK email or seen a presentation before. Okay. Okay, maybe half people. Okay. Maybe raise your hand if you've heard of the ZK email registry or built with ZK email Noir before at all. Okay, basically the people who built it, and that's it. Okay. Okay, so we'll go over that. Maybe what else? Raise your hand if you have your laptop and you want to hack on something, have something by the end. Okay, 3 or 4 people. Okay, cool. Okay, so maybe what we might do then is we'll probably do a talk and go from the basics. Yeah, cool, thank you. We'll go from the basics up until, oh, maybe also raise your hand if you've built with Noir before. Okay, so we'll maybe cut some of the Noir details because I don't know how much time we'll have to go into that. But okay, so what we'll do is we'll probably go over what is ZK email. Then we'll briefly go over why Noir is useful and some of the benchmarks there and what we found. And then we will explain how to make your own proof and why that's interesting or relevant. We'll explain some interesting use cases of ZK email, and then we can, I guess, that'll be the official end. And then for people who want to stay on for longer and work on making their own proof, we can have a much more intimate workshop session where we just get people making their own proof in 5 or 10 minutes. Sweet. Okay. So right. So that's going to be our rough roadmap. So we'll probably do something introduce what is going on, what is Noir, how is that useful, and then how does the dev tooling look. Okay, then maybe raise your hand if you would identify as a builder, you enjoy building stuff, you want to understand the dev tooling and the internals of things. Okay, that's most people. Sweet. Okay, so we'll focus on that aspect of stuff. Okay, so what is ZK email? This is review for most of you, but new for some of you. So the idea is that if you want to make a proof of some email that's been sent or received, the way that this normally works for anti-spam or anti-spoofing mechanisms is this thing called the DKIM protocol. The idea is that every email that's sent has an RSA signature from the sending domain of the SHA-256 of all the information in the email. So that would include the from, the to, the subject, the hash of the body, whatever it is you want to prove. That's signed with some private key associated with that specific domain. Now the problem is you could prove the signature directly, and that's what's used for spam prevention. But if you prove the signature directly on chain or to a third party, you have to reveal all this information to prove the signature is valid. So how do you get around this? Well, you can wrap this entire verification inside of a ZK proof. And you can hide stuff you don't want to reveal. Because the idea is that the point of ZKM is we built all these tool stacks and tooling and useful utilities to be able to do this really, really easily. And now you can prove any email within a proof and redact all the information you don't want to reveal. Okay, so why is this interesting? Well, okay, one, you get privacy. You can, anonymously prove things by redacting your own identity all throughout the email. And you can redact, sensitive information. Maybe you want to reveal that you have an account with some bank, but not what your balance is. So you hide, the balance and you reveal the bank or whatever. And so it's kind of useful. And you can think of if you go through all the emails in your inbox, you can prove, oh, I went to Noir because I have the Luma confirmation. And you can kind of think of really creative, interesting emails that'll let you do interesting proofs. How do you actually build these proofs? Well, you use regex to parse these emails. And then you just prove the outputs of the regex and you make everything else private. And it's provenant. These proofs are self-contained. You can prove them on chain. You can prove them on other services. You can give them to third parties. And that's pretty interesting. Okay, and then one maybe the most basic example here is let's just redact some information from an email and expose it. So we have some whistleblowing example where you want to prove you got some email and you just redact your own name from it. That's kind of level 1. That's if you have the most basic kind of proof and you're just using string redaction. But the idea is that you can extend this much further. You can build arbitrary kinds of proofs, and I'll introduce a tool that we can use to define what these proofs look like, and maybe stretch your imagination a little bit on what this could be. So I guess So why might you want some like abstracted system like the registry to make these kind of proofs for you, like a kind of a higher level on top of something like Noir or Circum or all these other ZK languages? Well, the idea is that these all have different benefits and disadvantages. Like for instance, Noir is extremely fast in the browser on the client side for client-side privacy. So every time you want client-side, we basically default to Noir. Circum is very valuable if you want, battle tested. This language has existed for 5 years, secures billions of dollars of tornado cash. You're going to use it for like super high value on-chain transactions. So then you want to use maybe something like a little bit more battle tested. Maybe you want to prove really large emails on a server. So then you'll use something like SP1 or RISC-0, where you have like a ZK VM running on a server, where it's not really possible to do client side, but if you have the benefits of a bunch of GPUs, you can make that proof. And the idea is that it shouldn't matter. Like, you just define your schema. This is the kind of email I want to parse. This is the kind of information I want to get out of it. And you define, oh, do I want client side or server side? And we just automatically choose the fastest one for you behind the scenes. Okay, so maybe like one useful exercise to jog the imagination is kind of thinking about things we can build and what those systems look like. So, okay, so let me kind of give like, actually I can just do a live demo of this probably. The Wi-Fi is fast enough. Okay, it is fast enough, great. Cool, so you can imagine that these are all emails we've taken from, like this might be, maybe I'll zoom in a couple times. These are all emails someone has taken from their inbox and defined a proof of that thing. So for instance, at the top, somebody took a Twitter email. What they did is they just extracted the Twitter handle from the email. So you prove you own a Twitter handle, you can prove that on chain, you can make a ZK proof, and you hide your own email address and everything else about your identity. Or you can prove you got accepted to a conference or rejected from a conference. You can prove you have a Netflix account, and that kind of is like, oh, I've had a Netflix account for this long, and so I've probably been watching TV for this long, I'm subscribed. It's kind of interesting. You can prove you merge like a GitHub commit. That's kind of interesting if you want to like, this is something that Jacqueline also worked on where you can automatically get reimbursed for merging in some commit. You can prove you're invited to certain events. You can prove your email domain only and not reveal your identity, but prove you're part of some company. You can prove you hacked or won some hackathon. You can prove you deleted your account. I mean, this kind of goes on forever. And so, and these are completely composable, right? Like I can do something like, oh, if I deleted my account and I'm booked at NoirCon and I booked a hotel in Denver, then automatically give me a 50% discount on something or the other. And so it's kind of like you can compose these in very interesting ways. But what actually is this registry and like what is going on here? So the idea is that, just to load. Okay, I'll just talk while this loads. So the idea is that this registry gives you this nice abstracted way to automatically define, new kinds of proofs and have them automatically compile to all those backends that we saw. So okay, concretely, let me go back to this registry slide. Great, okay. So the idea is that we wanted to make it as easy as possible for somebody to define a new kind of pattern. So for instance, they might say, oh, I want to prove I got accepted or rejected from some conference. They'll upload like some test email that they want to parse. And then we'll automatically extract, okay, this is like the from domain, this is like the email header, the body length, et cetera. You don't have to think about that. And then we'll like, the whole point of this is you want to use regex to define, oh, like, was the person accepted, rejected, et cetera. And so we have this like nice little Claude integration where it like takes your email, is like, okay, like, what is it, if you want to extract like the date or whatever, what is the regex I might create for that? And then we'll automatically select a regex for you. And this is kind of what the final configuration looks like, all the information. It looks nicer on the UI, but this at least gives you like the kind of programmer's view of what this is like, okay, you want to extract the proposal title, so we have a regex to parse that out. You have like the sender domain, you have the length, you have like certain like whether it's in the body, the header, et cetera, and this kind of defines how you parse this email. And this is substantially simpler than writing an entire ZK circuit from scratch for all the different like ZK circuit compilers that I showed in the beginning. And then it gives you like a GitHub style interface where you can see like the number of stars, you can fork things, you can see the number of people that have done things on it, kind of very GitHub inspired of like, how do you do version control in these patterns when emails change or when you want to take somebody else's pattern, fork it, et cetera. And then we automatically deploy, like kind of like Vercel would, like an automatic front end for you, and anybody can go to it, upload their email, and prove with your proof directly. And it'll automatically search their email for emails that match, et cetera. And so it's kind of like very simple because you just go through, you upload your email, you define your regexes, and all this infrastructure is already deployed for you, which is super convenient. Version history forks, I already talked about this. Cool, so maybe before we go to the registry, if you guys want to do like a brief overview of like what the Noir, like what is interesting about the Noir version, like what are all the kind of components that go into that, what are the rough benchmarks, how long will you expect a proof to take? I can pull up those slides for you. Yeah, what's up? We can do questions.
I just want to understand, you've got this like really cool experience for emails, but this could be used for any block of text, right? Like you don't actually, like an email is just a block of text. And if I use the proof of DevCon acceptance, I could have just faked the email and like written my own thing. Is that right?
So the email is not just a blob of text. The important thing about the email is the blob of text with an RSA signature. And so that's the thing where you actually get the provenance from, because only, whatever, devcon.org is going to send you an email from devcon.org, and they're going to have some public-private key. And it's very easy to verify once you have the signature. You can easily fetch their public key and verify was this actually a signature generated by them. So yes, if it was a blob of text, this would be trivial. We'd just be doing normal substring extractions. That wouldn't be very interesting. The interesting thing here is you combine it with the provenance from the signature, and that allows you to do all of these, like attach it to saying this is a real thing that you can't forge unless you have their private key. Yeah, but it's a good question. Like, how do you get security? Yeah.
If I were building like an application that integrated this,
yeah.
Would I need to go fetch the corresponding public key for the specific thing that I'm verifying? And do you guys kind of manage like a registry for it?
Yep. So basically, the Wi-Fi is just not very fast. But if you go to archive.zk.email, we manage a basically centralized archive of all of the public keys that we've seen and we know. And there's kind of this interesting algorithm that we've run also where basically if you have any two old emails from some public key, you can reverse engineer what that public key should have been. And so we automatically do that for you, and we'll kind of handle getting these what you might imagine are lost public keys. And I think I actually have maybe slides. I have a screenshot of that archive here somewhere. No, yeah, okay, so here, for instance, this graph is basically all of Hillary Clinton's email leak and whether or not we could verify the emails. And we put red if we couldn't verify it, meaning the public key is gone, and green if we could verify it, meaning the public key is still there. And so the whole point is you want to be able to verify these inboxes and these emails are valid so somebody doesn't just spoof whatever information they want. And so to get these old keys exactly, you kind of want exactly this archive. So if you go to archive.zk.email, you can search any domain. In this case, it's venmo.com. And then we'll just show all the public keys that we have or we've reverse engineered over time, and you can use those. And we also maintain an on-chain registry in which a kind of group of computers, 30 computers, kind of does a delegated multi-sig kind of thing where they all fetch the public key themselves, they all verify themselves, and they send it on-chain. So that's how we do the higher security stuff. Okay, right. So good question though. Back to the Noir stuff. If you guys want to quickly just talk about why is Noir relevant to this? How does performance characteristics look like? There's also, it says to do ZK regex, but we recently got some benchmarks from ZK regex, which are pretty cool, which lets us do all of this super fast client side. So yeah, I'll give it to you guys for a couple of minutes, and then we can kind of go into understanding how to kind of build your own app and other cool things ZKML has been used for. Sweet.
Sure. Is Mike?
Yes.
Does that work? Oh, it's for the camera. Okay. Okay, that's how. Okay, so this is gonna be slightly informal. I feel like it's better just to go to, here, I'll just pop open.
Are you going to the GitHub?
Yeah, it's gonna go to the GitHub.
Yeah, it's up there.
This one?
Yeah, exactly.
Oh, okay, so this is ZK regex. So it's gonna start with the
ZK
bench, and then, it's here. I'll come back to this. Okay, so it does take a long time to load. Yeah, so Noir, very fun. If you've written Circom, I mean, Circom's great, state of the art at the time. It's also really sucks to write. If you compare like what a ZK email circom circuit looks like and what this will pop up in the next 45 minutes with, it's much more ergonomic. I think that's like the first thing.
There's a screenshot in the slides, maybe that's
Is there?
place to start. Yeah.
Yeah, just, oh, there is a screenshot.
3 tabs later, anything. Next tab. Yeah, I think yours, like one of these, yeah.
Okay, so yeah, this is pretty much an entire ZK email circuit. And, a lot of this stuff is abstracted away, but the core part is like, you know, you're going to have a header. You want to take a DKIM signature and verify it over the header. So it's just that. There's a bunch of stuff going on under the hood here. You could like click into it if it was GitHub or you had it in VS Code or something. You know, it's going to do a SHA-256 hash. It's going to do an RSA signature verification. All you have to do is call this, though, to do that, which is like step 1. So this is an old version. Now we actually have the regex, and we'll do like the same thing that Circom will do. API, more or less the same, though. You want to get the signed body hash. You're basically going to give it the header. It's going to check that this is actually a valid spot for the body hash to be in. It's going to base 64 decode it for you, do all of that. Again, abstract it away. In this case, we're not partial hashing. Don't need to talk about that. We're just going to compare, like if you wanted to do operations over the body, you want to just ensure that what you're asserting the body is actually what was signed in the header. Do it like that and that. And then you're going to want to output things like the pub key itself. If you wanted to hook into the registry, you don't want to output like 18 different field elements. It's easier to hash it into one. As well as you want some way to nullify the email, which you know, there's different pros and cons, but the easiest thing that you can do is just hash the signature as well. And that, like, there's more you can do. There's a lot you can do with ZK-email, but this is like the full end-to-end functionality for a basic verification. So the first thing is, yeah, it's super easy to use. Second off would be, of course, now it's loaded. Talk about the benches. We can just pull up the benches from this, actually. These are actually a little out of date, too. I mean, do you want to talk about the benches, or? Okay. Yes, this is a little out of date. This is on an M1 as well. We, like, seconds ago benched it on an M4. I think we got, like, 2 seconds for this circuit. And that was in the browser with Honk. With multi-threading enabled, you should be able to do this in about 5 seconds. Witness generation should be, this should be like 4.25, 0.75, 5 seconds. So it's really quick. And like if you compare that to Circom, like you can do like a verification over the header before you run out of memory, right? More or less.
Small bodies.
Okay.
I mean, this is like maybe like a factor of 5 at least faster.
Yeah. So really like Circom with Icicle, you put that on the back end, it's probably going to be faster. So like in certain situations, it does make sense to use Circom or any of the ZK VMs. But if your priority is client-side proving, Noir is basically the clear choice here. And with regex now, we'll get to the point where it's feature parity, but essentially, if you have any sort of reliance on kind of anything on the client side, this is probably the best way to do it. What else? I think that might be.
Those are the main things, yeah.
And then there's regex, which I'll just pull that up and you guys can look at it. But actually, I will show this off really quick, actually. So yeah, this is the only difference. Like you saw the previous one, it was get body hash. Now it's this. So again, all that stuff's abstract. You have to generate regex if it's like non-standard. There should be, of course. Well, there's a bunch of the common ones in there already. Oh yeah, here they are. A bunch of the common ones in here already. So like if you needed any of these, you can go get them. But there's also the CLI for generating stuff. So yeah, ergonomic, private, quick. Those are kind of the bullet points.
Sweet. All right. Great. Yeah, okay, so now that we have like a sense of like what the abstraction looks like, what's under the hood a little bit, we can go towards kind of understanding, I guess, maybe we can do like a couple of like other applications to just jog your mind on like what is possible, and then we can move towards people making all of your own proofs and kind of just going through what that could look like. Okay, so cool applications people have done. One is like the exact same code we have works not just on emails, but on like general logins to things. There's already a group that did Noir JWT proofs. We have those also in Circom, and you can do those with exactly the same kind of regex matching, and you can prove you did certain login to certain websites wherever you want. So that's pretty cool. You can use like the whistleblowing thing to say like post confessions from your email domain. You say, oh, I own like a at, you know, I don't know, like berkeley.edu domain, and now I'm going to say like something about something at the school that I maybe don't want to reveal my main identity for, and you can use like TEEs for moderation, or now you can actually use Claude's new, Claude 3.7's new like signature to do LLM moderation directly, which is quite cool. You can do like email triggered transactions on chain, so you can use like an email proof to like send or receive, you know, money basically directly to or from emails. You can have emails approve of multi-sigs. You can have emails directly log into websites, like crypto websites, just fully with email, but you don't have to trust like some like, you know, person to MPC your keys for you and hold them. It's just kind of your email domain server is the only trusted party here. You can do account recovery. So maybe you have like some wallet and you want to make sure it stays safe even if you lose your phone. Well, then you could just add email addresses to your guardians. They confirm, and then they can recover your assets when they want to. And this all happens via these like ZK email proofs on chain. Cool. Okay, so I guess the most compelling thing I think now is we can briefly do question, then we can move to doing like a very interactive thing where we like define our own proofs, hopefully in like 5 or 10 minutes with the registry. But before we do that, I'll just take questions so that people who just wanted to come for the talk section can get the talk section. Yeah, do people have any like questions? Yeah.
Are there any like, bounds on the complexity of the regexes I could use?
Yes, there are bounds on the complexity of the regex. So this will again take 3 years to open, but let's, while that loads, I'll talk about it briefly. So the idea is that if you're doing regex in the ZK VMs, you have a little bit more latitude and flexibility because it can do the parsing via just direct opcode, so you can do like a couple more things. But if you want to do regex in like client side with Noir, you have to be a little bit more choosy about how you're going to do it. And so the main restriction here is that you have to deterministically move through the string. You cannot really like go backward. So for instance, you'll define like this DFA that represents the regex, right? So maybe your regex wants to match, you know, the letter M, the number 0, 1, then dash, then A or B, then a semicolon. Then you'd imagine that each character you're going to match, okay, is this an M? If it's an M, I move to the next state. If it's a 0, 1, I move to the next state. While it's still a 0, 1, I stay in this state, et cetera, until you reach the end. And this means you can't do things like lookarounds or, I mean, what else?
Like store previous match and then
Yeah, like things that like rely on long-range interactions in the regex that require you to go backward aren't really allowed, and things that are non-deterministic. So imagine you match something like, oh, match like maybe an A or a B, and then later maybe it exists, maybe it doesn't, and then later you match again an A, then and they're kind of contiguous, and your regex could either match, you know, the A or the B or the A later. You can't do something like that, so it has to be deterministic all the way through. In practice, this is like mostly fine. It's just like you can usually construct a regex that satisfies these things, and if you can't, then we can like work with you to do it. The AI is still not quite learned it. Like we're not prompting it totally that great, so it still sometimes puts invalid things in the regex, but we'll hopefully throw an error when that happens, and you'll see, okay, something's not working, and then we can work with you hopefully to resolve that. We had this blog post, zk.email/blog/zkregis, that goes through like the nitty-gritty details of how we think about these like different kinds of parsing and regexes and DFAs, and then if you kind of just replace like the gates with lookups, then you basically have like the Noir implementation.
Isn't there like some computer science results that like an NFA can always be converted to a DFA?
Yeah, so an NFA can always be converted to a DFA, but the problem is this means, it does it via this like multi-set kind of expansion, meaning that there is still, like you end up tagging your DFA with like up to exponential number of states. And it may not be directly a pass like of a single character each character of your string through your regex. So yes, you can convert any NFA to a DFA, but it may not be the case that you can, for instance, parse. Maybe you want to, when you say, oh, only this part should be public and the rest of the part should be private, that result kind of breaks down a bit because yes, it's deterministic, but now like someone could still manipulate what is public and what is private. And so it's a little bit, you have to constrain it a little bit more than just that multi-set expansion. But it's a good question, yes. Yeah. Okay, cool. Okay, that's all for the questions. That's like the main talk thing. If you want to see links or like read more, I'll put up like some QR codes. Right, this is going to take, okay. Wow, this actually loaded pretty quick. Yeah, so Telegram on the left, website next. The docs is where we define all the stuff. On the right side, I think, is the slides. Yeah, these are like, yeah, not all the slides, but some of the slides. So hopefully this can help you. Yeah, what's up?
You see you have multiple prover backends. Is there like like a snark that you compile into from like Circom, or like, is there like a chosen snark that like, Noir uses?
Yeah, so Noir will use like honk or plonk, and then Circom will use grot16, SP1 and RIS0 will use Starks, and then we'll recursively aggregate it to a grot16 proof if you want to verify on chain. And it's kind of like the things we're like looking for. It's kind of determined by like you define what you want. Like you say, oh, I want client or server, and I want the fastest possible. And we'll determine, okay, is your email long? Okay, if it's long, we'll use the ZKVMs. Okay, is your email on the client side? Okay, if it's on the client side, we'll do this. We'll do Noir. Okay, are you trying to verify on chain very cheaply? Like, are you on an L1 or something? Okay, maybe we'll opt for grot16 because maybe the size really matters. So it's kind of, we'll sort of make the trade-offs for you based on like the functions you call in the SDK, basically. And you can imagine that like the SDK interface, I can also pull up like a brief screenshot of what that looks like.
So the proofs get like posted on chain.
Yeah, they can be posted on chain, yeah. So when you actually want to do this like inside of your app, you basically like, it's like roughly like an 8-line thing. Okay, well, that's annoying. But you can kind of see the idea of like, you'll import the SDK, you'll call, this is the blueprint I want. Okay, I want to prove like I got rejected, I want to prove Twitter or whatever it is. You'll like create the prover and define whether you want to be local or not, and that'll automatically choose whether you use Noir or Circom. And then, let's see if I can, okay, well now it's reloading.
You don't actually know which
So you can manually override it. So we do like give you an option to say, okay, I want to use this specific one. But in general, like we'll check, okay, like are you like, and then we'll let you give you a function to generate your inputs, generate your proof, and then verify on chain. And based on whether or not you call verify on chain or whether or not you're calling is local, we'll just like make the choice for you. But you can manually override it and say, okay, like I don't know, like Noir equals true or whatever. We haven't added that functionality yet because we haven't yet upstream Noir, but Noir should be upstream in the next week or two, at which point this will become relevant, and we'll let people manually choose. Yeah, but it like the point was we wanted this to be like you actually integrate into a front end in like 5 minutes, and so like we really optimize like lines of code on the front end for somebody to go from like zero like nothing to like a ZK-ML proof.
But if you're creating a system like where you need like, or perhaps like a verifier that can verify all of your logic, and you have potentially multiple proof systems that are inferred from your logic, it's not really like deterministic which proof system you're using.
Right.
Okay.
So the idea is that like, the idea is that the user should be able to choose, right? Like if you want the ability for people to post all kinds of proofs on chain, you can say like, yes, SP1 equals true, Noir equals true, Circom equals true. Or you can just have the one by default, which will deploy a single verifier based on your case for that single prover type on that single compiler. And that'll just be kind of what you use. And so it's sort of like, you can define if you want to have multiple different verifiers on chain to support all these different kind of use cases, or if you want to focus on one and you say, okay, we really want to minimize our attack surface. We don't want people to use all these different verifiers. Like, a bug in one verifier would then compromise the whole system, and so we're just going to like select, a single one and say we're going to stick with that one. And so people can kind of make their own decisions on what they want to do, and yeah, we'll give like a sensible default. But yeah, correct. You might have like different. If you're doing some production system, you might want a little bit more control. We don't have that stuff. The specific choosing the specific provers right now in the SDK, but like presumably as soon as we've added Noir in, that we'll just add that choice. Yeah, good question. Yeah.
Do you have some defaults on like which chains to post to and like integrations with that?
Yeah, so right now it works on any like EVM compatible chain. So you can just, when you select verify on chain, you just set your RPC URL and it'll just send it to that RPC. And you define like we'll send you like this is a contract where we deployed it, et cetera. Currently, like you can just parse in any RPC of any testnet and we should be able to do that. I think right now it's on like Base and like ZK Sync and like Optimism and Arbitrum and maybe like one or two more, but it's kind of like, and Sepolia. And so it's kind of just like, and then when you want to put it onto like a mainnet, like a real L2 with like real money, then, then the cost of verifying public keys and stuff comes into play, and we'll probably just work directly with you to be like, okay, like probably point to this verifier and like be careful about these things. And then, again, you can just set the mainnet RPC, and then you have to be a little bit careful about gas, but it's kind of, the hope is get people onto testnet as fast as possible, and then we can worry about mainnet kind of more manually. Yeah.
It seems super chaotic to like auto choose the proof system, but I kind of like it.
It's chaotic in the sense that like this SDK is built for people who like have no clue what ZK is, right? They just want to like verify something from your inbox, and they like don't want to think about a ZK system. And yes, I agree. Anybody who knows like if you're coming to NoirCon, you should probably be specifying, okay, I want to use like this specific proof system, because you probably have the background to be like, okay, I want like this kind of proof with these kind of trade-offs. But like our whole point was that like I think that like ZK proofs can be useful outside of like the very narrow blockchain context we define them in. And if you want that to be the case, then like we better not be having people choose between like whatever 8 proof systems that like for which trade-offs are like somewhat nebulous to them. So it's kind of like our belief is kind of like have a sensible default, but let people choose if they care. Yeah, and yet to see if it'll work. Like we've kind of like only seen Circom proof so far. But I'm hoping that as we add these more backends, like it ends up happening. And some of them we have to just make the choice for you. Like the email, if your email is like contains a PDF or an image, like sorry, like you're not using Circom or Noir probably. You just have to use a ZKVM. And so it's kind of like some things like our hand is a little bit forced, but other things like we can leave up to the user. Yeah. No, this is great. Questions are great. I'm sure other folks are curious too.
Do you guys like have any resources on like complexity of email to like what you think the sensible defaults are, and like how we should think about like if the PDF is this big, go with this one, or like if you're putting an image with this.
That's a good point. We should add a page in our docs for that. Right now it's mostly just in code, but it's true that like I could just define the rules for you right now in like 30 seconds. I can say like, oh, like if you're gonna do client side, do Noir. If you're gonna do like, if you have a body longer than 1,000 characters, you should be using, or maybe longer than like 2,000 characters. Okay, if you have a body over 10,000 characters, you have to use SP1, or you have to use a ZKVM. If you have a body over 2,000 characters, you're kind of towing the line. It's similar, but like ZKVM will maybe be faster a little bit. Most attachments are going to take you over that like immediately. And then, yeah, those are like the main rules of thumb. If you have like more than 10 regexes, like maybe you should be using, not be using Circom. Yeah, those are like the main rules of thumb. Yeah, it's pretty simple.
Is there a condition where you reach for Circom over Noir?
Yeah, so we reach for Circom over Noir when you are verifying on-chain in a production setting. So for instance, like Noir, for instance, is only like 1/3 audited, right? So like we're kind of comfortable deploying stuff to testnets, and we're comfortable deploying stuff where there's less than like $1,000 going through it or something like that. But the moment you're gonna like go over that limit and you're at like a money limit where you can't replace all the money, then like probably, at least until Noir is fully audited, probably should be using Circom. And if you want to do fast server-side proofs on a GPU, Circom is still the state of the art. So if you're kind of like small bodies, server-side proofs, still Circom will be like, we have proofs with like 5 regexes and fairly long headers happening in like 6 seconds on a server in Circom. And it's like that even in Noir would take like probably like double the time is my guess. Yeah.
And is the audit on the proof system level or the compiler level?
Yeah, so the audit we're waiting for is on, so the proof system I think has already been reviewed because it's like published or something, but the main thing we're looking for is like, is there a bug in the compiler, like the Noir compiler? And like that, we're pretty confident there are bugs in the Noir compiler. So we just really want those to get ironed out before we let people kind of verify on mainnet and kind of lock a lot of money in it. Like I would say if you're doing this for like identity proofs or something, it's fine. Yeah, use Noir, like it's no big deal. But like if you're doing account recovery, probably use Circom. Okay, so yeah, you had a question as well.
Yeah, and are these all the same flavors they all use, like PIOB,
More or less. Yeah, there's like some nuance with Fry being like a little bit different, like kind of slightly different, like PIOPs, but like it's kind of like like if you want to verify all these on chain, like you're going to end up with a like snark at the end, and it's going to likely be ROT16 no matter what you choose. Although some of the like honk verifiers seem to be pretty optimized. I mean, are competitive, but still not quite as efficient. Yeah.
that's good.
Yeah.
I would love to see like the code, like how do you choose? Is that open source?
Yeah, all of our code is open source. Everything is on our GitHub. If you go to github.com/dk email, you'll see everything. We like the current state of the registry is basically we have all of the like provers working for SP1, for Vis0, for Noir, for CirCom, but the registry right now only supports CirCom. And so we're hoping like over the next few weeks, now that we've kind of finished all of those MVPs, to add them into the registry and like make that choice. But it's kind of like that's the hope is that we're like, we're kind of promising that if you make a proof on the registry, then we will automatically, like within the next like month or two, like be able to generate all of those for you. Yeah, it's pretty fun. Yeah.
I'm not a developer, so.
No, it's great. No, I'm yeah.
So is it that what's happening here is that somebody is writing the proof for like a specific sort of thing that they want to prove in an email, and then anybody can use it?
Exactly. So that's exactly what the point of the registry is. It's like this kind of like public version control system. Let me go back to the registry. It's like public version control system where if you want to make a Twitter proof, you don't have to think through, oh, I got to upload an email, I got to define a regex, will it work, will it not? You can just be like, oh, yep, that Twitter one, it's been started 8 times, probably works, and you can just go with it and it'll just probably work. And so the point is that like, it's kind of like there's some like, yeah, you can avoid like some headache and just reuse other people's proofs and look at on-chain activity, okay, it's been used like 100 times, okay, it'll probably work. So yeah, it's kind of like this nice version control system. Yeah, and you don't see all the past version. Like if you go in, again, the internet's going to take forever, but if you kind of go into the proof, eventually a version control button will pop up and you'll see the whole history of all the times the Twitter proof has been modified, which roughly correspond to either like bugs we had to update, features we had to add, or the email template itself updating. You can see the history and you can say, okay, I only want to verify on version 4. So I want to be very sure that I'm doing this and it's not going to change. You can also like pin the specific version. So yeah.
Cool.
Yeah.
You just have like a test suite repository of existing emails?
Yes, we have a test suite repository of existing emails. If you go to our GitHub repo and you just search like .eml, you'll see like we have, almost like maybe 5 to 10 of our repos have like pretty extensive tests with .eml files, and you can just pluck those EML files and use them for testing yourself. You can also just download one from your own inbox if you have like a very specific need. But yeah, we try to provide like, we have like a Proton Mail email, we have like a Gmail email, we try to make sure that like we have pretty good coverage. Yeah, it's a good question. Yeah, so like for instance, you would just go here and then just do like whatever, like file, like .eml is like probably good enough, and then it'll come up. Maybe file, path, okay, there we go. Let's take a second. Okay, maybe, okay, we'll debug this, but you can kind of just search, maybe we can just do .email, will this work? Okay, you can at least now see like roughly where the .emails are, and if you start scrolling, you'll start seeing like .emails pop up. Anyways, yeah, you can find it in the GitHub. Sweet, okay, so now what I was thinking is we have, 17 minutes left. So we will, folks who want to just come for the talk, feel free to stick around and ask questions, but we'll probably try to do like a 15-minute thing where, the folks who want to make proofs, pull out your laptops, we'll pull up registry.zk.email. We'll try to like actually find an email from our inbox, actually try to define a new proof, and hopefully at least one person by the end has something compiling, but we'll see. Okay, cool. So that's it for like the main talk section. We're going to move into the workshop session. Sweet. Okay.
Tools we need to install, or?
We can do this all in the web UI, and then when you want to like actually import into your app, you can import the SDK. Yeah. Okay. Okay, so yes, how's it going to work? So you're going to go to registry.zk.email, and then you're going to like log in on the top right. Sorry, I don't have like, let me see if I can get a bigger QR code up. Maybe this, I don't know if this QR code goes to the right place, but anyways, you're on your laptop, so you'll have to type it, but let's see. Yeah, okay, this QR code goes to the right place, great. Yeah. Okay, once you're logged into your GitHub, let me know. Okay, I'm going to move to the next step. Okay, so basically now we want to create a blueprint. So on the top right, we're going to hit create blueprint. Okay, and then we probably want to find like some interesting email in our inbox. So we're going to go to our inbox. Hopefully I don't have any super sketchy emails. And just like scroll through your inbox and see like, is there something interesting you want to prove? Like maybe, you know, an event confirmation from ETHDenver that you recently got, or maybe like some flight confirmation, or maybe something else. And let's like, well, I'll show you how to download that email, and we can kind of start making that proof together. Okay. Let's see. I mean, here's like an Uber trip that I could take. Okay, why don't I take this Uber trip? This might take a second to load. Anyways, once this loads, you'll have like 3 dots in the top right, and there'll be a little like download original email button. So once you download that email, then you'll have the .eml file locally, and you can upload that into the create blueprint on the registry. Man, is there a faster Wi-Fi here? Let me know what the.
Start Quantum Fiber seems to be a public network, but usable.
Okay, great. Let's do that instead. I think my hotspot is particularly effective here. Okay, great. So now the email's popped up, and I am going to, so the 3 dots in the top right, and then you're going to see like download message. I'm just going to do that, and that will let us get the email. All right. Great. Cool. Okay, so now it's downloaded. I'm going to go back into this registry, and I'm going to say pattern name like Uber One membership or something like that. We're going to use this proof to prove that you're subscribed to Uber One. Okay, great. And then I am going to grab this and drag it in. Okay, sweet. Yeah, and you'll see that like this email body, because it has a lot of images, is like quite long. Like this email body is more than that 10,000 character cutoff that I mentioned to you guys. And so we'll have to basically skip like body hashing in this scenario.
Curious, could you do like a proof of an email transformation and then upload like a condensed email?
We could, but at some point in time, we have to prove the SHA-256. And so,
Okay.
yeah, and so that kind of like, Norm makes it a little bit faster. SP1 Rizio make it really fast. And so it's kind of, yeah, eventually this body hash restriction will be lifted, but for now, let's, if you have an email that's too, ideally a more text-heavy email would be easier. Maybe we'll just say Uber trip workshop. Okay, sweet. So prove you took an Uber trip on Sunday. Okay, great. Cool, and then now you'll see as we go to the next screen, it's automatically fetched out like what these values should be. So like it'll fetch out, okay, we're looking for from uber.com in your inbox. Center domain is going to be uber.com. The max header length is going to be, this value it's figured out is in fact the max header length. And we're going to skip body hash check because our email body is too long. Okay, I can like walk around and see like where people are kind of at. If people kind of need a hand. Okay, sweet. Okay, we're there. Yeah, so you saw the too long. So then now if you go to optional details, you'll see like, yeah, so we're skipping that body hash check because it's too long. Sweet, okay, cool. Okay, looking at something else. Let's see, any other, okay.
I am first step.
Yeah, you probably need to just put a pattern name in order to go to the next step. Yeah. Anything with no, like just so no spaces and stuff like that. Just like yeah, should be good. Okay, great.
Which template was it?
So we were just creating a blueprint in the top right. Yeah, we just create a new one up here. Perfect. Yeah, you should be at that screen. Any like anything without spaces should work in that. Yeah. Awesome. Great. Perfect. Yeah. You also don't have to do Uber. You can do like whatever email you want. It can be kind of up to you. Yeah. Oh. Yeah, I should be done in the yeah, should be done. Yeah. Sweet. Okay. Great. Okay. So so once you've on the previous screen uploaded your email and named it, and you've gone to this screen. Feel free to also not use an Uber email. You can use like whatever you want. It's more fun to do it with a weird kind of email. Okay, so now we're gonna go to the next step. Okay, so now we can like, there's a bunch of like quick header extraction, so we can like automatically parse out subject, receiver, sender name, sender domain, timestamp. In this case, let's just parse out the subject. So, right, so this first one's gonna be empty, so I'm gonna delete this, and you'll notice it's like added the subject in automatically. And this is a regex that will expose the subject, and will automatically expose like the test outcome. So you'll see that like on this email, we're exposing your Sunday afternoon trip with Uber. And I can be a little bit more fancy, like I can do stuff like, just expose a day or whatever, but let's just stick to something easy like subject or recipient or something like that for now. And you can try the like AI fancy thing, but like hit or miss right now. Okay, I will just check if people are kind of able to get there. Okay, great. Okay, so one thing is the first one is likely still empty, so you could maybe, you should delete the first one because we should. Oh no, is that the second one? Oh, sorry, we should put the delete at the bottom. Okay, you scroll up a bit. Yeah, that's a good UX feedback. Okay, so now you have whatever. Well, now you deleted one of these, but whatever you have. Yeah, whatever you have. Okay, cool. Great. Yeah. So you should be good. If you just check the output looks good, then you should be good to go. Like the kind of same. Yeah. Exactly. Great. Okay. Perfect. Yeah. You have to delete the first one.
So.
Okay. So you have subject. Yep. Okay. Cool. Did it simulate correctly? Yeah. So delete. Yeah. Delete this empty one. Okay. Great. Please add at least one regex. Okay. Sorry. Just try deleting from the top. So yeah. Just delete this one, and then just select subject again. So just unselect and select it again. Yeah, okay, that works too. We have this weird system where this should really be a plus, but whatever. Anyway, okay, so now I think you have like 4 subjects, but yeah. Okay.
Oh shit! Yeah, I see what you mean. Let me go do
Yeah. Okay. Anyways, yeah, you can figure it out. Yeah. So now when you submit, we'll compile it into like a circum circuit basically, and then add it to the registry and everything. Yeah. It might be annoying. I know Chrome has like a thing where you can drag it from the top, but I don't know about Brave. Anyways, yeah, it should be good. Sweet. Yes. Okay. Great. Yeah. Perfect. That looks like a subject. Brilliant. Yeah. So now, okay. Cool. So a decent number of you seem to have kind of gotten at least one of these outputs to work. If it isn't, I can help manually debug with you afterwards. But then you just hit submit blueprint. So there's an option to save your email. So people will, so you can send, if you consent, you can send your email to us to help debug. Sometimes people remotely will do this. We can help them debug, but by default, we obviously don't share, we don't save any of your emails because that would defeat the whole purpose of this entire application. Okay. Okay, so now if you kind of search your own GitHub handle, you'll be able to see the status of that pattern. I obviously have a lot of patterns, but okay, I just passed it somewhere. Let me do like whatever, what did I call it, like shop maybe? Yeah, okay, so you can see that mine is now in progress, and in maybe like a few hours you can come back and all the stuff I said will be deployed for you. Right now just with Circom, but hopefully we can work with Jack and Ian in the next few weeks, we can get Noir up, and it'll be super cool, yeah.
So does the backend system generate the proving verified keys?
Yes, backend generates all that stuff for you, and it'll we want to add an automatic trusted setup link for people doing like Groth16 circuits basically, but for the nicer transparent things like Noir or SP1 order, you don't need that. So.
Do you have a way to query proving verified keys that are been generated?
Yes. So if you go to a generated proof, So let me get rid of these. Maybe I'll go to Twitter. So now here, if I click download, then I can download all the assets involved with that, including the proving keys, verifying keys. So like here, the keys.zip that has exactly what you're saying, Solidity contracts, the circuits, yeah, everything is available. So you can kind of manually take this and then build your own project. Yeah. Sweet. Okay, we have 5 minutes left, so I can keep answering questions, going around helping people.
What's next on the horizon? Like, what's the hard problems that you guys are thinking about?
Yeah, there's a couple of hard problems. So one is how do we, like, sometimes people want to hash outputs, like, oh, I want to hash my email address. And we're like, well, wait a second. If you hash your email address as an output, you're not really hiding it. Because if I had a good guess as to what the email address could be, I could just kind of reverse that hash, right? I could say, oh, probably hashed Ian's email. I know Ian's email. Let me try it and see if it works. And if it works, well, then now your hash has leaked your anonymity. So how do you get these like hashes that don't leak anonymity? Well, one way to do this is like a verifiable, oblivious, distributed pseudorandom function. And it's like this thing where you have this big network of computers, and it basically takes like some input like an email, generates more randomness that you can use and then salt a hash. And that way, only somebody with like specific key that is rate limited, like that is like sending to these computers, and these computers have like can verify the person at least a little bit, is like not trying to spam a bunch of emails, only then calculates that hash for you, etc. That's one thing we're like actively like researching and building. Another set of things is just like making things like faster and better and supporting more things. Like here, like we want to ideally parse like images out of PDFs and like all this crazy stuff, but it requires us having a PDF parser and then having an image parser and then maybe running like ZKML on top of it with like Ezekiel and then maybe running like, like other weird interesting things, but it requires us having like really good fast parsing. And so a lot of these problems are around like, well, PDF parsing is pretty non-trivial. So like how do you get that in a circuit? And like with SP1 0, it's a little bit easier, but it's still super expensive. So like, okay, building precompiles for that stuff, making the workflows here just like easier, making like the really security critical stuff really good. So like account recovery, like compatible with 7702, 7579, deploying onto like real wallets on mainnet, like generic verifiers, Noir, Circom, etc. Keeping in touch with the latest in like ZKVM space. Defining new kinds of proofs, like just as we define more and more proofs, you just run into like weird things like, oh, this email didn't verify because of this weird edge case. And I have to go in and fix all the circuits because it's like weird edge case. So it's kind of like some amount of that as well. But yeah, I would say it's like a healthy mix of like research, product, yeah, dev tooling, yeah.
Yeah, I feel like the space is like you're just drinking out of the fire hose.
It's huge. It's enormous, yeah.
Too much of it.
Yeah.
Determine which proof system to use. Do you have like what decision algorithm?
And we have like 8 if statements. It's like, it's like it's not a complicated thing. It's like very like if this proof would fail on that system, then just don't compile on that system kind of thing.
Yeah.
And so yeah, yeah, it would be cool if we had some like nice automated decision algorithm, but it's more of like we have like a very vague cost model, and like we just like do this very dumb calculation and just like select the right one. And like in reality, what this is going to look like, we'll probably just compile it for all the proof systems, and then some of them will just fail, and they'll just be like, all right, you're just not getting that proof system. And then we'll log it in our notes. Okay, SP1 failed on like a email from Uber. Okay, well, I go look at it, and then yeah. So it's kind of like it's a very dumb. We've admittedly like not implemented that specific decision algorithm, even though I can like explain to you what exactly that code would look like if you asked me to write it down right now. But yeah, it should be hopefully live soon. You can, yeah, I mean, we should really like have the docs page and put some pseudocode. But the bigger issue is just right now the registry only supports Circom, so we're just like, once we add those proofs, then we'll have this problem and then we can do it. Yeah, if you want to be part of helping with that, like I'm down to jam on heuristic algorithms or something. I think that would be fun.
Because there's like some proof systems where there's a certain amount of tokens we could not possibly connect to them all.
Right,
Or like
yeah.
specific like encodings for them.
Yeah, exactly, yeah, yeah. Or like something that just way fast, like SHA-56 is way faster in ZKVMs, RSA is way slower in ZKVMs. Like you just kind of get trade-offs on different things. regex is like way faster in Noir because you're directly hitting a lookup table. And so you're just like, yeah, it would be cool if we had like a very accurate cost model and we could just choose. But we just do heuristics and it's so far like basically correct.
I think one of the fears that I have is like if you have a specific problem that you're working through, one person may have a slightly, like, expect a similar problem, get a proof out, have a different verifier, and not be able to verify the same flavor of problem.
Yeah, so this is part of why, like, probably in the front end we'll have, or in the proof generation step, once we add more backends, we'll probably have some checkboxes of, which ones do you want to generate, and maybe some warning of, like, by the way, we don't expect this proof system to compile, just a heads up. You can still try, but it likely will fail, and maybe that way people can reproducibly build it. Yeah, it's a good point. Yeah, we should add, we'll probably, I mean, we just haven't really, we're sort of just getting into this problem, but yeah, reproducible builds are important, I agree.
Yeah,
Yeah.
I mean, allowing people to like define specific rules for like what things verify with what. Like,
Yeah,
could
yeah.
Actually result in reproducible.
That's true, and the reality is, like, they're probably just like, we can do all these heuristics, but like the most likely thing is we just compile all of them and let you choose based on which one succeeded, and then it's like pretty reproducible. Okay, cool. We're at 3 p.m. If you want to keep asking questions, I'll be outside for like another half hour or whatever. We can keep jamming. Yeah, and then you saw all of our links, zk.emails, where everything is linked. Sweet. Thank you for coming.